Okay, today now we will do the section 2.4, right? Page 24p3. This lesson is for Friday lessons because we are going to miss every day about 1.5 hours, right? 1.5 hours and 2 periods. So because of that, I thought of putting a recorded session for each Friday, right? So here we are going to discuss the inverse function, right? Now we have discussed that in grade 10 also. Inverse function is the actually, if you take y equal fx, right? Y equal fx, it is, I mean, the inverse function of fx is denoted by y equal f inverse x, right? So first thing what you should know is, now in some cases you will see sine squared x, right? Now this is actually equal to sine x whole thing square, right? And you have seen now you have seen f square, right? F squared x, right? So actually this denotes fx, and the meaning of this is fx, right? But if you take f inverse x, right, y equal f inverse x, right? Inverse, this is a special thing, right? This is the, I mean, how it is known, inverse. The idea of that is the reverse mapping. Now function is a mapping, right? Now if you take like this, right? So this is there, right? And it maps, you say 1, 2, 3, you take 0, right? Minus 1, 3. It is going to map into 10, 11, and we'll say 100, right? So this is how, I mean, if this is f, right? If this is f, the f inverse will be, right? F inverse will be, right? F inverse will be, now if this is f inverse will be 10, 11, and I said 100, yeah, 100, right? That is going to get mapped into 0, minus 1, 0, minus 1, and 3. Actually, if f goes in this direction, right, f inverse goes this way, right? And another thing we have to know, I mean, in all cases we don't get a f inverse function. Now the trouble is, now this is a function, right? Function, and f inverse also should be a function. Otherwise we don't call it no inverse function. But now this person can't be can't be a mapping, right? So there are, now if you take 1 to 1, right, surely you can have a inverse mapping. That means this fellow should get mapped into this. But if you consider a mapping, right, we'll say like this mapping, we'll say this is 1, 2, 3, again I will put 0, and this is, we'll say 10. Now this is a function, right? This is a function, but the trouble is we can't have a f inverse function. If we consider the opposite mapping, right, this one element is going to get mapped into 2, right? Then it violates the definition of the function. So what you should remember is, right, in all cases there are no functions, inverse functions, right? Okay, so now simply if you want to find the inverse function, what you should do is actually just flip it, then it will go, or else you think of the right. So now for example I will just write, now if you take this function, we can just define as this fx, right? This equal, now you all have seen like this 0, minus 1, right, and 3, right, 3. And if we say sorry, 10, 11, 100. 10, 11 and 100, right? And we can say when x is equal to what? When x is equal to 0, and when x is equal to -1, and when x is equal to 3. So the inverse function will be, right, of this inverse function will be equal to other way around, 0, -1, 3, and when x is equal to 10, and when x is equal to 11, and when x is equal to 100, right? So now this is the inverse function. So in this form also you should be able to tell. And if you have a mapping diagram, like this mapping is there, then you should be able to draw the inverse function also. Now this is inverse function, right? So now, right, in grade 10 also, now in the examples also they do some several methods to find the inverse function. We will discuss that. But another thing I want to say, one thing I said, now always f inverse is not there. And also another thing you should remember, right, a function, for example, like this, f inverse is, there should be a property if, right, if f inverse is the function, is the inverse function, is the inverse, right, function of f, right, function of f, then this property should be there, right? There is a notation, f inverse is equal to x, right? And we can say f inverse f should be equal to x. Actually, we'll see what is the meaning of this. Actually, if both cases are there, only this function is going to be f inverse. There are unique situations. I will not take it now. Right? There will be unique situations where this property will fail. Right? And also, yeah. So another thing, when we take the inverse function, now this now f is going like this, and f inverse is like this. Right, so if you take, this is the domain, right, domain, and this is the range, right, f inverse will should have the range as the domain, range of f should be the domain, and also he should give the output as the domain of this f. So that also just remember, right. So here what I told was both ways, it should have the same. Now, right, that property also you should remember. Right, so if we take, we say x plus 2, we say fx as x plus 2, right, fx as x plus 2, right. Now we know from, x, we say 2x plus 2, right. So we know, grade 10 we follow the method. This method, actually there are some small issues, but I won't talk about that in this lesson because it will be little extra thing, right. But you should be aware. Now for example, you can just put here, now we know this is actually y equal to 2x plus 2, then we will put x here and we will put y here plus 2, and we are going to make y as the subject. So y is equal to x minus 2 over 2, right. So actually this is f inverse x, f inverse x. Now what, see the property, I hope you can see, right. So this is, right, so we can say here f inverse x is equal to x minus 2 over 2. This is our inverse function and this is the fx function. Now we'll see what is meant by f inverse. So that is equal to f inside that f inverse, right? F inverse x, right? So f inverse x is like this, x minus 2. So for this we should put 2, right? X minus 2 over 2, x minus 2 over 2, x minus 2 over 2 and plus 2, x minus 1 plus 2. So that is going to equal, when you expand this fellow get cancelled off and you will get x minus 2, x minus 2 plus 2 is x, right? X. And now we will see, right? Now we will see what is f inverse f. What is f inverse f? I will do it here, right? F inverse f, right, is equal to, right, f inverse f is equal to f inverse fx. So f inverse x is this one, we have to put here, right, 2x plus 2. So here 2x plus 2 minus 2, right, minus 2 over 2. So see, right, this also 2 get cancelled off, right? 2 get cancelled off, 2x divided by 2 is x. So see, actually these two are actually two different expressions. F inverse x is a different expression, right? And also f inverse, sorry, here f inverse, here f inverse f, it's a different expression, but still it gives the x. So that is what I mean, that is that is why it is defined. So there are some special functions sometimes, this one f inverse f and f inverse, they are going to be different. Then or some cases it violates. So that case we can't consider f inverse as the this one. So that is there, and that was why I explained. Now there is another thing. Right now I told about the mapping. Right, told about the mapping. Now we will see, actually now we know f inverse f is going to be x. So actually if you take a graph or the Cartesian plane, right, Cartesian plane, how will f inverse look? So for example, we will just take a small definition. Fx is equal to 3, 2, 1, right? When x is equal to 0, right? X is equal to 3 and x is equal to 10. Alright, 10. So if we draw this fellow's mapping, it will look like this: 3, 2, 1, 0, 3, 10. So this is the mapping, right? Then we know, we have to switch it. So f goes from this side and f inverse x get mapped into this side. So what would be the f inverse x, right? Would be these are the x values, these are the alright, okay. So 0, 3, 10 will be the output. So when x is equal to 3, when x is equal to 2 and x is equal to 1. So this is how it looks like. Now we'll see, if we put this in a Cartesian plane, what would happen? Right? What would happen? So if you take the Cartesian plane, right? The f is going to be for 0, 0, 3. So 0, 3. For 0, 3. Right? So here the cross is there. And then for x3 it's 2, for x3 it's 2. We will put here closer, right? 3, it's going to be 2. So roughly maybe we can say here 2, right? For x10 it is 1. x10 it is 1. So this is the mapping of fx. Now we will mark with red color, right? What would be the mapping of f inverse x, right? For x3 it's going to be 0, so it is here, right? I'll put a circle x3. For x3 it is going to be 0. For x equal 2, right? For x equal 2, right? X equal 2. If it is 3 here, here. So x equal 2, right? It is going to be 3. X equal 2, it is going to be 3. So he comes here. So a little bit of this side, right? And x equal 1, it is going to be 10. X equal 1, it is going to be 10. Like this. So what you will see is, right, actually what you should see is, we are actually swapping the x and y. So it should form now my actually drawing is not good, right? So it should form a reflection. So here this person comes as a reflection. I think this one I have made a mistake, the cross. So actually he should will check. Yeah, the three crosses. This cross will check. It is the when it is 3, x is 2. Okay, that is right. And then it's a when it is 2. X is 3. So we have a little trouble. I will pause the video and see. Actually the trouble was the scale. Now here 3 was here, but this 3 is very short. So we will bring the 3 up to here, right? Up to here. So the black 3, right? Black 3, this length we will put it here, right? It should be 3 here, and we will take it off, right? And the red dot should come here. Red dot should come here, right? Red dot should come here. Then the other one, when the first one, when it is 3, right? When it is 3, it should be 2. So 2 should be roughly, when it is 3, the 2 should come here. 2 should come here, right? 2 should come here, roughly. So now you would see, right? 2 would come here, right? Now you would see, right? Actually what happened was, now these 3 so these 2 here, these 2 got reflected, right? And this one got reflected from y equal x. This one, these 2 are reflecting each other. Here these 2 are getting reflected from the y equal x. So what would happen is, actually if you have a graph, right, to get the f inverse x, you should reflect from the y equal x. So please go through the section also in the book. Now I gave idea, right? And if we consider the graph, right? If we consider a graph, right, like this, right? And if we say there is a graph like this, we say, okay, it is now very difficult thing I am going to draw, right? Like this. So this is f equal x, y equal fx, y equal fx. So if I am supposed to draw, right, now this is not the graph, this is the graph. If you are supposed to draw the inverse function, what you should do is first draw the y equal x, because we are swapping x and y, because the mapping gets swapped, right? So this is y equal x, y equal x. And now I don't have any artistic skill, right? I will try my best. So the red color I will draw, right? So here it should be the mirror image, right? Mirror image, right? Mirror image. I will put it like this. Okay, right? This, right? Mirror image, and this. So this should be the inverse function. This should be the inverse function. Actually, why I erased here was, right, because I saw some trouble. If you reflect it, there will be some true values. So then it's not going to function, not going to be a function. That's why I made it straight here, right? Straight. Then I'm safe. So here also, roughly, I mean, it should be like this. If it takes a turn, we are in trouble. If it takes a turn, we are in trouble. Because for single x value, there are two values. Then this is not going to be a function. So, but now this is a very safe function, right? So this is what we should do. And sometimes like this, there can be another one. I mean, for example, right? For example, if you have a graph like this, for example, if you have a, okay, still we are in trouble. I will draw a graph like this. Now fx, if we draw, I mean, from two sides, right, two sides, and like this, if we draw, right, now he is crossing the y equal x. Still you have to reflect this fellow to this side, this one to this side. So what should happen is like this, right, like this. So there is a small issue. I mean, we will put like this. We will shape it, right. Anyway, the mechanism to draw this one I explained, right. So now we will go to example 1, right. Example 1. Okay, I forgot to stop the right. I will do the actually example 1 means it's the example 13, right? This is in page 24 P3, right? So they are asking us to find, they have given hx, right? Find the h inverse x. So hx they have given, right? Hx they have given as 2x squared minus 7 for all x greater than 0, right? For all x greater than 0. So greater than 0. So here actually now all have practiced just to replace x and y and I mean get that. But see the explanation they have given. Actually hx you can consider, right? Hx you can consider, I mean there are sub operations, right? So first thing is, now if you take the domain, right, x greater than or equal to 0, so all positive real numbers are there, right? First operation what is going to happen is, when you take a value of the domain, it gets squared, right? So it gets squared and you will get an image, right? You will get actual, I will say image 1, right? Image 1. So this is the domain, image 1, right? And then what you are going to do is, whatever the image values or the output, whatever the output you got, you are going to multiply it by 2. That means 2, I mean I will say 2 multiplied by 2. Right, value, yeah, so multiply it by 2, right, whatever the value. I don't want to write this 2x squared, then you have it's alright, 2x squared, but it's meaningful, I mean it's like a ambiguous, so we will say multiply by 2, so here is square, right? So then actually now this I1 is going to be the domain, you say domain 2 for this function, and then it is going to produce another image, so I will say that is image 2, right? And then you are going to subtract minus 7. Subtract minus 7 from all image. Then you will get the final image. Final image. Final image, you make it as I. So, but and also here the 3 kind of, when you are operating this, right? Operating this, whatever the output values, right? Behave as the domain for this function. So actually there are 3 functions combined here, right? Okay. So now if we are if someone took a value like we will say 3, it is going to get square, right? It is going to get square and again multiply by 2 and minus 7. So how to get the original one, right? You have to put plus 7, right? And then you have to divide it by 2, right? Divide it by 2, and actually you have to take the square root of x, square root. Then you will get the original. So that is the idea, right? That automatically happens now by looking at this. Now the operations were this, right? When you take, so actually what should happen, what should be the h inverse x now? H inverse x, right? H inverse x. When you take a value from the domain, now when you consider h inverse, so here actually this is right? I will erase this show. Right? So h inverse x. So hx, right? Hx is equal to 2x squared minus 7. So here, actually this is the fx, which is 2x squared minus 7. And now we have to find, right, what is the h inverse x? H inverse x. Then what should be the h inverse x? If you take the x value, now domain is this, that value should be plus 7 and then divide by 2. So divide by 2 and square. So we will write that. I mean, now we are not going to use the grade 10 method, just putting y here and x here and making x as the y, x and y, and then making again y as the subject. Without that, this is the fundamental understanding, right? So x we are going to write, right? So if you take x value, it should get added by 7, and then whole thing should get divided by 2. Whole thing should get divided by 2. Finally, you should get the square root to come back here. So this is h inverse x. But if you do our normal method also, now we know y is equal to 2x squared minus 7. But there are a lot of things which I am not explaining. I mean, these things are having some small fundamental mistakes you can do, because we are not going to cover it up in this section, right? So what we will do is we will just put x here and we will put y square minus 7, and we are going to make y as the subject. So x plus 7 is equal to 2y square, and then x plus 7 divided by 2 is equal to y square. Then y is equal to x plus 7 over 2 square root. It is the same, but you should, although it is the same, you should have the ability of doing in this method also. Right, so that was the example 3. Example 13. Now I will do the example 14. Example 14, it says they have given a fx function, right? Fx function, this is actually page 24, right? Fx function as 3 over x minus 1, 3 over x minus 1, right? And they say surely the x is belong to R, x is a real, right, R, and x is not equal to 1, right? We can't have that, because if you put 1 here, fx is infinity, right? So this is a this is a this domain is actually the one is missing, right? Now what they want is by changing the subject. Now they don't want to draw the diagram just x and y, but we have to be a little careful, right? Now if we take this what sorts of values we are getting? I'll draw the function of this and then I will pause the video. No, I thought I will just do it. Right? So just we will this one will function. So here y is equal to 3 over x minus 1, and then this fellow we will put x here, and 3 is equal to y minus 1, right? So now we will cross multiply. Y minus 1 is equal to 3 over x, and then y is equal to 3 over x plus 1. So actually this is the f inverse x function. Now we will see actually what would be the domain domain. So domain of this by changing this one. That's all right. But at home, right? At home, because all are doing now because I don't have time, right? Just draw this graph, right? So you can draw 1 over x. Right, 1 over x, it goes like this, right, 1 over x, and then multiply it by 3, right, and shift it by, shift to plus 1, and then see the reflection and see what is the domain and the range. So that part, kind of homework, please do that, because I have done several, a lot of questions explaining domain and range, those things, right? So you all also please draw this one and take the reflection from the y equal x and see what would be the what would be the range and the domain. There can be issues. Right? So I'm going to stop this one. Example 14, right? And then I'm going to go for. Go for example 15. Now this is a little special case, right? Example 15. Example 15, they are asking us to consider fx is equal to square root, right? Square root of x minus 2. Right now here where x belongs to R and x is greater than 2. Actually now on Monday I will ask this, right? At home, right now this is again like homework, right? Thinking task. If y is equal to x square, can you tell me the domain and the range? Right? And also if y is equal to right, domain and this one, y is equal to square root of x, right, and to the power 4. We will do like this, domain and this one. So for x, domain and range, and also x square root of x, right? Now the function is square root of x and whole thing square. So what would be the domain and what would be the range? So do this at home, then I can check whether you all actually did the homework also, right? Monday I will take this issue. Then you can consider y is equal to square root of, right? Square root of minus square root of x, whole thing square, right? And then what would be its domain and what would be its range? If y is equal to, other one, y is equal to square root of minus x, whole thing square, what would be the domain and what would be the range? Actually you will see, if you just simplify, right, in all cases, I don't say, many cases it becomes like y equal x, right? and some in another case y equal minus x. So I mean these two are having the same domain and the range, right? But when you have these square root and those things, it is going to be different, right? Just do this at home and see. Right, so we will come for this, right? Now actually we have to see so this one and the state the range of. So part A, what they want is the range. Part B, what they want is f inverse x. They are asking us to find f inverse x and its domain and the range, right? Those two we have to find. And also sketch f in y equal x. So part C, sketch, right? Sketch both fx, right, and f inverse x in the same Cartesian plane. So we will see how we are going to handle this. Okay, so here, I mean, we have to be a little careful, right? I mean, how are we going to plot this? So actually, we'll take that now. We can consider this fx as y. So y is equal to square root x minus 2. Still, I mean, we don't feel comfortable, right? This is not a normal pattern. But if you make y square is equal to x minus 2, now it is going to be a little familiar pattern. That is a quadratic. So I mean, I know there are some students they don't so now we know, right? If we take y is equal to x square, y is equal to x square plus 2, y is equal to x square plus maybe 3x, something like that. Anyway, generally we know how to plot y equal ax square plus bx plus c, right? So and like this. So these are going to be like parabola, like this. So here if it is y and if it is x, right, it can have like this any place, and sometimes it crosses the y-axis, x-axis, sometimes crosses, touches the x-axis, sometimes it doesn't cut, so there is no rules. So we talked about lot of things, this form, right? So that is y is equal to ax square plus that one, right? Parabola, and we talked about the determinant, and if the determinant is less than 0, what would happen, and also if a greater than 0, what would happen, and what would be the line of symmetry, and where is the coordinates of the minimum point. Lot of things we have discussed. So this is a very familiar pattern, y is equal to ax square. But now when you square it, right, when you square it, you will get a pattern. Actually now y is actually a quadratic. So here y square plus 2 is equal to x, right? Y square plus 2 equal to x. So actually this is, now we have swapped x and y, it is a quadratic, right? Now if you take ay square plus by plus c equal x. Now we consider the other way pattern, right? So here he is going to behave as we can't say this is a function, we are in trouble now. If you plot this, you will see it is going to be a parabola in the Cartesian plane, right, like this. He can stay in many places, but this is a mapping. The most troublesome thing is when you take one x value, he is going to have two values. He can have two values of y. So what would happen is it's going to be a mapping. So we don't call this one, this ay square plus by plus c, this pattern we are not calling going to call as a function. It is a mapping. Now we'll say, right, actually what has happened here, now we get an equation. Now this is the pattern, y squared plus 2. First we will plot the y squared plus 2 mapping. right? So mapping, how we are going to do that is, we will have the Cartesian plane, right? This is actually x, this is y. Now we know this is y is equal to x square. So where will be the equation of x equal y square? It is the opposite, like this. So this is actually what y square equal x, right? This is the pattern. So this is the mapping. But now we have a wonderful thing, right? Now this is a mapping. We can't talk about even inverse functions, and we can't talk about domain, we can't talk about the range, because he's just a mapping, right? He will have a set A and set B, right? So but there is a trick, right? Oh, sorry, this is y squared, now x, no. So what would be, now we have to consider, right, when we come here, we have to consider y squared plus 2 equals x. Y squared plus 2 equal x. So what has happened is, now here it is a transformation to the right. So this fellow will go from here, right? This fellow will go from here, like this. Sorry, like this. So this would be 2, right? X equal y square. So actually now here there is a little oversimplification, right? You have to tolerate that. Now I will explain those things. Now from here to here it's the same, only I square both sides, and also I added 2, it is the same. But this fellow is giving a parabola like this, and it is going to be a mapping. But if you see, right, but if you see the question, they have limited the x, right? So that means all the x values, right, all the x values will be always more than 2, right? So now we have trouble, right? Now when we take this graph, right, always greater than 2, right, always greater than, so this is going to be a positive value. And we'll see whether they have given equal to also. Yes, equal to also they have given, right? So we can have 0 also. So always y is going to be positive, always y. But when you went like this, we got a oversimplification and we got a pattern like this, but it's having extra y values, right? But from here you can decide y is always positive. So the y values, we have to consider only the y values which are positive. So although it will look like a parabola if you take the this type of equation, but here he is taking, so actually this is, right, this is y is equal to square root of x minus 2. Actually what I erased was right, what I erased was y is equal to minus square root of x minus 2, because when we square this also he gives this. Here if you square it, y square is x minus 2, you will get this. If you square this also, he will get this. So when we are squaring, actually the original graph was this. When we squared it, we actually inserted another unwanted graph into our equation. So that trouble was there. This explanation I will give it only in the beginning. After that I won't talk. Right? So here now only we have to forget that, this part. Right? Then 2. Right? Now from here we will try to answer the part A range. So this is the function. What would be the range? Range would be always, we have to put what? Range. We have to actually put the projection of the graph onto the y-axis. So part A, the range would be, right, y is greater than or equal to 0. Right, that is very simple. Now, I forgot. Now, f inverse x we have to draw. Right, f inverse x. Now, this is here. Now, what we have to do is we have to draw the y equal x line, straight line. Right, straight line. And if we take the mirror image, right, mirror image. mirror image, what would be the shape? So here it's 2 from here and it will look like this, same mirror image, right? So here for part B, we will just swap the y and x, and we will, I mean here also you can see, I mean from the graph, surely this is this inverse x, this is actually y is equal to x squared plus 2, x squared plus 2, right? But he gives both sides. We have to take only the right hand side of this. Right. So when we take the reflection also, right? I mean, if you swap it now, swapping part, we will do it here. So here what I did was I took it up. Yeah. So here I will erase this part and I will show how we are going to get the equation of the inverse. So the original function is y is equal to square root of x minus 2, and instead of y we will put x, and instead of x we will put y. So here we get x square equal y minus 2, and y is equal to x square plus 2. So our normal quadratic pattern. So x square is going from here, right, and he gets lifted by 2 units. And from the reflection also I got it. Actually now this reflection part, this is the part C. Already I have done that. Right now part C. But now here we get this. And also we should know, right? Also we should know the okay, that's all. Sorry. And the domain will be domain will be x. Domain will be x greater than 0. So here when you put all the values of 2 or more, y will always get 0 and 0 to any positive value. So that is the domain for the F inverse. Here always values for but y inverse x, right? So I came up to there, what else? Right, now we have to range I told, right? F inverse x, we have to talk about the domain and the range. So I will erase this unwanted thing. This is like a right. Then so here what would be the domain? Domain of f inverse x is, again we can see the projection of y onto the x-axis. So surely domain is going to be x belong to R and x is greater than or equal to 0. What would be the range? Then we have to consider, now we are talking about f inverse x, right? We have to consider the projection of that onto the y-axis. Right, now this I think maybe this is the 20th question I am talking about range and domain. Right, now you all should be skillful. So that would be x belong to R and x is greater than or equal to 2. Yes. Right, so we did the example 15 also. The last example, example 16 also, I will finish this in this recording, right? And then the exercises we will start it on Monday. So please go through this theory part which I did today and the examples, and maybe you all can do some very easy questions from exercise 2D during the weekend, right? And get ready. So I will go for the difficult questions from exercise 2D, and then surely Monday we can go to the section 2.5. It's a very interesting part, 2.5, and then maybe Tuesday we will be, maybe Tuesday or Wednesday we will be able to finish the chapter 2. It was a very long chapter. Maybe I feel it might take up to Wednesday also. Okay, we will do the example 16, and this will be the last question which I am going to discuss, and then we will meet on Monday, right? So they have given a function fx, right? Fx is equal to x squared minus 3, and the domain they have given x belong to R, and x greater than 0. On Monday I will ask why they gave x greater than 0, the reason, right? Whether you all can answer that, we'll see, right? So some discussions we will have regarding this. So this one is actually a familiar thing, our x squared, right? X squared is going like this, and minus 3 he goes below, right? This is minus 3 and this is x and this is y, right? Like this it goes. So now what they want is the first one. And another thing, x greater than 0, our normal pattern, x greater than 0 means we should not consider this part, right? So he is not there. And this fellow will continue, I mean, he won't become vertical, right? A slanted straight line, he will go like that. So that is the pattern. Right? Now what they want is actually find the f inverse x. This we will just swap it, right? And then I will swap the x and y and get it. But the real method is drawing a graph and see how it comes and then decide the graph. This is like we are doing a little blind way of approaching the f inverse x, but still that could be valid, right? Now here what we have to do is part A, just write fx is equal, fx means y is equal to x squared minus 3, right? X squared minus 3, and we will change the parts. That means x and y. X is equal to y squared minus 3. So here we get x plus 3 is equal to y square, right? X square is equal to y square. So now this is actually, now if you take, this is a pattern, right? Pattern like this. I talked about that. Now when we consider this situation, I mean it is going to be a quadratic, right? Y squared is like this and minus 3, he has come to this side, but we will not think of that, we will just keep as it is, and then x plus 3, right, square root is equal to y. So this is the inverse x, right? And now we have to be very careful what would be the, right, now by looking at this, what would be the domain of f inverse x? So here we will put as f inverse x, right? X. So what would be the domain? We can't have negative values inside the square root. So if you put minus 3, we are okay, right? Minus 2, we are okay. But if you have minus 4, we will get minus 1. Then we are in trouble. So the domain should be x such that, right, x belong to R and x greater than or equal to minus 3, right? And actually when you take the reflection from here, we can see, right? Now they ask us to sketch both on the same axis, so we will consider this as the part C, right? And we can just draw the y equal x, here y equal x, right? Y equal x. Like this, right? And then we will take the reflection. So here reflection would be now minus 3, here also same distance minus 3, right? And like this. Like this. So I will go maybe this one should go little up, otherwise it won't be nice, right? This one also on x minus 3, we will bring it here, minus 3, and then y equal x is like this, right? And it is a parabola, right? Yeah, it will go like this type. Oh my God. So here now the domain of F inverse X is, this is our F inverse is, that would be
Explain the teachers now here.
belong to R and
Right, yeah.
X greater than minus 3.
Respect means we outreach.
Now they are asking us to actually solve part
We
C.
have to be kindness, patience, and understanding.
Part C.
Jesus respected everyone.
Part C. The solutions of
Now in our society,
if
when we see a big person, we respect.
solutions of if x equal f inverse x
Because they are all sets are
equal f inverse x. Right? Actually now here the solutions are here. This is the only place where it gets it's intersected. So there should be only one solution. Right? And actually there are several methods. We can take this one
and understanding.
solve this. X squared minus 3 equal x.
Reading now,
Right? And also we can take this one.
This is reading
Square root of
Everyone understand?
square root of square root of x plus 3 equal x.
Don't read now. See.
Also we can find
This is about
x square
the message
minus 3, right? X squared minus 3, right? And also we can consider this right? X squared minus 3, x squared minus 3 is equal to square root of, right? Square root of
Not here. This is
x plus 3.
when I wait for this.
But this would be also same. I mean, this would be also little same. We will consider the square root cubic. So we will not consider this, right? We can consider maybe the easiest one, this one. Right? So x squared minus 3 and y equal x, and it should give only 1. So I will do it here, right? So we can say when fx is equal to f inverse x, right? Then x cube, right? We can say this one fx, right, is equal to x y x also. So this is actually we are solving y equal x. Then it's going to be x square minus 3 is equal to x. Then x square minus
because I will be
x, right?
This is our
Minus 3 is going to be 0.
presentation.
Then x is equal to, we will put minus b plus or minus square root of b square minus 4ac
This is also
over
very
2.
If you don't like something, change it. If you can't change it, change your attitude.
Then minus b is 1 plus or minus 2, right? Plus or minus 2 b square is 1.
Next one,
Right? B square
no
is 1 minus 4,
when comes small,
right?
is ever wasted.
And c minus 3.
No act of kindness, so it will be always.
So here we get
So now this is about bullying.
1 plus or minus square root. This is
Can you
12
accidentally bully
and
someone?
13 over 2. But here you will see, right, we get a negative answer if you take the minus, right? That means actually it is giving the solution here also. We are cut. So we have to take the positive value. Therefore, if you intersect that, right, we can say x is equal to 1 plus root 13 over 2.
So you to the whole
Right. Okay, children, we'll start the rest of the section on Monday, and we will try to cover much as possible. I hope you all will do these questions, at least the examples and some few easy ones, and get ready with the section, right?